This is what sarcomeres look like whenever muscle contracts. They move back and forth like so, but they never shrink. All of this muscle contraction occurs because of the neuromuscular junction. This is where a neuron meets a muscle. In this situation, the neuron releases acetylcholine, which causes a sodium influx within the muscle. This then releases calcium. This calcium comes in through the sarcoplasmic reticulum. If you look closer, you can see what happens during muscle contraction at a molecular level. This is an actin strand. The G cells are represented by the blue balls that are wrapped around with tropomyosin, which is represented by the white pipe cleaner. Then the troponin complex is represented by the yellow and green balls. The calcium that enters through the sarcoplasmic reticulum binds to the troponin, which then opens the cross bridge for the myosin heads to attach to the actin. This is a myosin strand in the myosin head leaflet. The orange represents the ADP, while the red represents the phosphorus molecule. The myosin heads with the ADP and phosphorus are attracted to the new opening that the calcium opened, and then cross through the cross bridge and attach to the actin strand. Here, the ADP and phosphorus are lost, but ATP then comes and separates the myosin head from the actin strand. It then returns to normal position, and the ATP is then broken down into ADP and phosphorus once again, restarting the process. Rigor mortis is something that happens post-mortem. The muscles quickly contract and the myosin heads attach to the actin. But there is no more oxygen left in the body, so therefore no more ATP can be made. Since ATP cannot be made, the myosin heads stay stuck to the actin. Eventually, enzymes will come and break down the myosin heads, which detaches the myosin from the actin. This then releases the muscles and causes the body to go back to a looser position.